Blockchain technology came with this huge promise, right? A totally decentralized, unchangeable, and secure digital world. But what if that whole promise could just be broken? Imagine if one person, just one bad actor, could grab control of an entire network and just bend it to their will. Well, that's not science fiction. That's the fundamental threat we're diving into today, the 51% attack.
Hey everyone, and welcome back to CodeAccessHub. This is the place where we, take all that complex tech stuff and make it super accessible for everybody. We love breaking down the big ideas into lessons that actually make sense, and believe me, today we are tackling a big one.
I mean, really think about that for a second. What if you could literally rewrite history? Like, imagine you could just go back in time, erase a payment you just made, and boom, the money's back in your pocket. Meanwhile, the person you paid, they're left with absolutely nothing. It sounds like something straight out of a movie, right?
Well, in the world of blockchain, it's not a fantasy at all. It is a very, very real security threat, and it has a name, the 51% attack. This is an exploit that goes right for the jugular. It strikes at the very heart of what makes blockchain so special. That decentralized, unchangeable ledger of transactions. Yeah, its entire history.
Okay, so what exactly is a 51% attack? You might also hear it called a majority attack. Basically, it's what happens when one single person, or a group, manages to get their hands on more than half of a blockchain's total computing power. What we call its hash rate. Once they have that majority control, they can do pretty much whatever they want. They can rewrite transaction history, they can block new transactions from ever getting through. For a while at least, they become the absolute dictator of that digital world.
All right, so how in the world does someone actually pull this off? I mean, how do you hijack a network that's supposed to be decentralized? Well, it's basically a multi-step digital heist.
So let's break down how this digital heist actually works. First up, step 1. The attacker has to get that magic number, over 51% of the network's hashing power. Then, step 2. They completely disappear. They go dark and start secretly mining their very own private version of the blockchain. Okay, step 3. Since they control most of the power, their secret chain starts growing way faster than the public, honest one. Now, step 4. Once their chain is officially longer, they just release it. They broadcast it to the whole network. And this right here, step 5, this is the killer move. See, blockchain protocols are built with one simple rule. The longest chain is always the truth. So the network sees this new longer chain and accepts it. The honest shorter chain, it just gets thrown out, orphaned, and all the transactions on it are just gone, erased from history like they never even happened.
Okay, so now we know the playbook, but what's the actual damage here? What are the real consequences? And maybe even more important, what's stopping this from happening to every single blockchain out there all the time? Let's get into it. Let's talk about the consequences and the absolutely massive price of power.
And yeah, the consequences are catastrophic. The one that everyone fears the most is called double spending. Think of it like a perfect form of digital counterfeiting. An attacker spends their coins on the real network, maybe buys a car or something, and then, poof, they use their power to erase that transaction, getting all their coins back. They keep the car and they keep the money. They can also reverse other people's legitimate transactions, or even launch what's called a denial of service attack, basically blocking anyone else from using the network. But honestly, the biggest damage of all? It's the total and complete loss of trust. That alone can send a cryptocurrency's value straight to zero overnight.
So with stakes this high, you've got to be asking, why isn't this happening all the time? And the answer really boils down to just one thing. For the big, major blockchains anyway, it is unbelievably, almost astronomically expensive and difficult to actually pull off.
Just take a look at this number. To even try to attack the Bitcoin network, an attacker would have to spend more than $7.9 billion. And that's just on the specialized mining equipment. That's not even counting a single penny for the electricity bill.
And yeah, it goes way beyond just the hardware. The other costs are just staggering. The electricity you'd need, it's immense. I mean, Bitcoin's total annual energy use is about the same as the entire country of Finland. That's insane. On top of that, you need perfect timing, perfect execution, because if the attack fails, you, the attacker, could lose every single cent you invested. Honestly, these insane costs are the #1 thing stopping these attacks.
So this massive financial wall does a pretty good job of protecting giants like Bitcoin. But for the smaller cryptocurrencies, the so-called altcoins, it is a completely different story. They just don't have the same amount of mining power on their networks, which means the cost to attack them is way, way lower. And that, unfortunately, makes them much more vulnerable targets.
And here's where things get even scarier. and a lot easier for the bad guys. It turns out they don't even have to buy all that hardware anymore. There are services out there like NiceHash, for example, that basically act as hash power brokers. They let anyone rent huge amounts of mining power for short periods. This just slashes the upfront cost down to almost nothing, making attacks on those smaller networks not just possible, but actually pretty practical.
Okay, so this brings us to a potential wrinkle, even for a behemoth like Bitcoin. A single attacker? Probably not going to happen. But look at how the power is actually distributed. Just 3 major mining pools. We're talking Foundry USA, Antpool, and Via BTC. Together, they control over 72% of the entire network's hash rate. Now look, these are totally legitimate operations, but this much concentration of power means that if they ever, for whatever reason, decided to team up, a 51% attack suddenly becomes, at least in theory, very possible.
And that brings us from the world of what if to the world of what happened. Because this threat isn't just theoretical, it's very real. We have seen several high-profile digital heists where attackers have actually succeeded.
Yep, take a look at this. Back in 2018, attackers successfully rewrote the history of Bitcoin Gold, and they walked away with $18 million. Ethereum Classic? It's been hit more than once, with one attack in 2020 letting the criminals get away with $5.6 million. Even smaller projects like Vertcoin got hit for over $100,000. These are not just numbers on a chart, people. This is stark proof that when a network's defenses are weak, the consequences are incredibly real.
So, as you can imagine, these real-world heists have basically sparked a security arms race. The entire blockchain community is now actively developing new defenses to try and build stronger, more resilient chains that can actually fight back against these kinds of attacks. And a few key strategies are starting to pop up. For instance, some networks are making it take longer for transactions to be confirmed, which makes an attack take more time and cost more money. Others are building in penalty systems, like something called slashing, where if an attacker gets caught, they automatically lose their own staked tokens. Ouch! But maybe the biggest defense of all is a really fundamental shift in how blockchains decide what's true in the first place. So you've got the classic model, which is called proof of work. This is what Bitcoin uses. Here, security comes from having the most raw computing power. But the whole industry is kind of shifting towards something else, proof of stake. In a proof of stake system, it's not about who has the most powerful computers. It's about who owns the most coins. So to launch an attack, you wouldn't need to rent computers. You'd have to actually buy up more than half of the network's entire cryptocurrency. And that is a mind-bogglingly expensive thing to do. And we've seen this play out in the real world in a huge way. When Ethereum made the big switch from proof of work over to proof of stake, the theoretical cost to launch a 51% attack just skyrocketed. We're talking over $49 billion. That move instantly made it one of the most secure networks on the planet. At the end of the day, the goal is just constant evolution. There's a great quote that kind of sums it all up. The future of Web3 depends on our ability to tackle these challenges, turning vulnerabilities into strengths and creating a more robust and secure digital future for all. And really, that's what this whole security arms race is all about. Which, of course, leaves us with one final big question. In this constant cat and mouse game, between the people building this stuff and the people trying to break it, is it even possible for security to always stay one step ahead? Or is the next huge vulnerability just sitting out there waiting to be discovered?
Hey, if you want more clear explainers on complex tech topics just like this one, do us a favor and make sure to subscribe to the CodeAccessHub YouTube channel. We break down these tough subjects every single week.
Thanks so much for watching. This is CodeAccessHub. Access, learn.